Well, hello again, students. So I just realized that I had been talking to myself for the last like 4 or 5 minutes. I did not realize I hit the pause button and left you hanging at the end of that last example there. So let's complete that, and then I will actually continue with the screencast that I just did for the last 5 minutes all by myself. So the first of the second videos, if that makes any sense, I believe left you off at the point where we had just found out what it took to complete the square. So we were at y equals 6 times x squared minus 4x plus 147. I drew the square. We had x squared and we had x and x, and this is half of b, and b is negative 4, so this was negative 2x and negative 2x, so this was negative 2 and negative 2, and we decided that this needed to be a positive 4 because negative 2 times negative 2 is 4. Okay, so let me make sure, nope, no pause button, I'm good to go. So y equals 6 times x squared minus 4x plus 4, and then outside the parentheses this gets a little bit tricky. It's minus 6 times 4 plus 147. So let me take a minute to explain this 6 times 4 here. Normally in the past two examples we just subtracted whatever we added here. So I added 4, I would subtract 4. But in the previous two examples I also didn't have a number outside the front of my parentheses. With this number outside the front of my parentheses, it gets distributed to each term inside the parentheses. So when I distribute the 6 to the x squared, I get the 6x squared that the problem started with. When I distribute 6 to the negative 4x, I get the negative 24x that the problem started with. But then I have to distribute the 6 to the 4 that I added in there, which means instead of adding a 4, I'm actually adding 24 to this problem. So if I put in 24, I need to also take out 24. And that's what this part does here when I do minus 6 times 4. Okay, so now continuing with factored form, or to get to vertex form, I'm going to factor the x squared minus 4x plus 4, which factors into what I have in my square already. So x minus 2 times x minus 2. The outside minus 24 plus 147. Since the parentheses are identical, like they always are, it's the whole purpose of completing the square. X minus 2 squared, and then negative 24 plus 147 is a positive 123. And there is the vertex form of that problem, and the vertex here would be 2 and 123. Okay, so before I cut myself off, I had gone through, or I had told you that I would do an example involving the ax squared plus bx plus c, where we're actually using the letters, and I'll show you a formula that you can use if you remember, and you wouldn't have to go through all of these steps. Okay, so if you wanted to complete the square using just general form and letters, same steps apply, but using letters, of course, creates a little bit more difficulty than using numbers because I can't actually do division or multiplication when I want to and change numbers. So I'm still going to separate out the x squared term and the x term and leave the c on the outside. Because there's a number in front of x squared, I have to factor that out, so that goes out front. When I divide by a here, this cancels, so I'm just left with an x squared inside. When I divide by a here, nothing cancels, and I can't do b divided by a. If they were numbers, I could get a new number, but here I can't, so I'm left with b over a times x plus c on the outside. So it starts to get a little bit confusing here. You can just follow along. You don't have to take the notes unless you want to, and then start taking notes back at example C. Okay, so here I would still have the x squared, and here would be half of b, and b in this case is b over a. So it's half of b over a, which when put together is b over 2a. So this is also b over 2a. Now these are multiplied by x because of where they are in the square. So now the outside of my square says x and b over 2a and x and b over 2a. To complete the square, I multiply b over 2a by itself, which means I get b over 2a squared. Okay, so now let's put it all into a nice equation, shall we? Y equals a times x squared plus b over a x plus, that complete, b over 2a squared. Then I have to subtract that on the outside, but I have to multiply it by the a that I took out, so a times b over 2a squared plus c. So now remember, this can be factored into what I have over here and squared, so y equals a times x plus b over 2a, the whole thing is squared, minus a times b over 2a squared plus c. And this, if you can remember it, is the formula for turning general form into factored form. You can just identify a, b, and c in your general form equation and then use those letters to put them in this vertex form equation. However, I think instead of remembering this crazy formula, it's easier to just go through all of the steps. You can decide what's easier for you. Okay, so finally on to example C. This is right about the time in the last video that I noticed that I had stopped recording myself 6 minutes prior, so good thing you're still hearing me now. So Nora hits a softball straight up at a speed of 120 feet per second. If her bat contacts the ball at a height of 3 feet above the ground, how high does the ball travel? When, sorry, get being interrupted here. How high does the ball travel? When does the ball reach its maximum height? So we have back to projectile motion. So that equation from the last screencast and from the do nows and your notes was y equals, we had ax squared plus v sub 0 x plus s sub 0. So because we're in feet, feet means that a is equal to negative 16. So I have y equals negative 16 x squared plus VO is the initial velocity that she hit the ball. So the speed was 120 feet per second, so it's plus 120x. And S sub 0 is the initial height, and it was 3 feet above the ground, so plus 3. So here's the equation I'm going to be using throughout this problem. I'm going to just rewrite it up here so that I always have it when I have to go back and erase some stuff. So 16x squared plus 120x plus 3. Okay, so there's the equation. When does it reach, how high does it travel, and when does it reach maximum height? So, from the investigation, I believe it was step 7, we can find the x-coordinate of a vertex by using a tiny little formula. So, x-coordinate of vertex is equal to negative b divided by 2 times a. So once I identify a, b, and c in my equation, so here's a, b is 120, c is 3, I can use this formula to find the x-coordinate of the vertex. So why do I want to do that? Well, if you think about the flight of this softball, if I have my person here, okay, with a bat in her hand, and she hits the ball, here comes the ball, hits the ball, it says it hits straight up at a speed of 120 feet per second. So the ball's not actually going that way. She hits the ball straight up into the air. So it goes like whoop, 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 whoop. So even if you hit it straight up, it's going to do some kind of a curve to come back down. So the vertex would be the highest point that it gets to. How high does the ball travel? That would be the highest point. When does the ball reach that maximum height? That would be my time. If you think about this on a graph, okay, the height of the ball would be my y value, and when it reaches that would be my x value. Okay, so let me erase my adorable little picture here, and let's do some calculations. So they're telling me that negative b, so b is 120, so this is negative 120 over 2 times a, which is negative 16. So that equals negative 120 divided by negative 32, which is 3.75. So that is the amount of time. So that actually answers the second question. When does the ball reach its maximum height? I'm just going to put 3.75 seconds. I'm going to leave that there right now, and I'll answer the whole question together at the end. How high does the ball travel? Well, if it reaches that maximum height point at 3.75 seconds, that's my x value. The height of the ball is my y value. So how do you think I could find y? If you said plug it into the equation, you are 100% correct. So once we find the x-coordinate, we're just going to take that 3.75 and plug it into x into my equation here, because x stands for time. So y equals negative 16 times 3.75 squared plus 120 times 3.75 plus 3. So doing some solving, this is negative 225 plus 450 plus 3, which gives me 228 as my answer. So that answers how high. So 228 feet. Because this is an open-ended real-world application problem, my solution should have a thoughtful, written out sentence. So the ball reaches a height of 228 feet at 3.75 seconds. Maybe I should put a maximum height of 228 feet at 3.75 seconds. And there we go. Using the investigation to help complete that real-world problem. So you'll finish up your Do Now quiz from the beginning of 7.3, and then we will do some practice on this stuff. See you in class.